Whenever you have an equation with just a square root on each side, like this, the first thing you want to do is get rid of the square roots. And how do you battle a square root? Square it. So the first thing we're going to do here is we are going to square both sides. The only time you can do that, well, there's complicated problems that this is not true for. But for us, a square root has to be alone when you square it, if possible. So here, both square roots are alone. So we're going to square both sides. When you square a root, it just makes the root go away. It doesn't affect what's inside of it. So squaring a root just turns this into 2t minus 7 equals t plus 2. The green square root sign and the red 2 just basically knock each other out. So we have 2t minus 7 equals t plus 2. And now this is an Algebra 1 question. Solving for t. So we're going to try to get the t by itself. We're going to subtract this t over here. T minus 7 equals 2. And then we're going to add the 7 to the other side and get an answer of t equals 9. So 9 is our answer. One thing that we have to be careful of, whenever you square both sides, you run the risk of letting in answers that don't work. So what you have to do at the end is you have to check your answer. So when we put in our answer, this one works because you get 11, square root of 11 on each side when you put the 9 in, so it's a good answer. Sometimes when you square both sides, you'll end up getting it one where you end up with negative 5 on one side and 5 on the other side, and it doesn't work. So you have to be careful. All right. Let's try another one. In this example, there's only one square root, unlike the first example. And so before we go to square both sides, we're going to have to square both sides to get rid of that root. The root has to be by itself. So before we square both sides, we have to move the 7. So we're going to subtract 7 first to the other side, and we get the square root of 4x plus 8 equals 2. So your goal at the beginning of each problem should be to get the square root by itself. So now we're ready to square both sides. So we square the 4x plus 8 that's in the square root sign, and we square the 2. The square on the left just gets rid of the root sign. That's its only role on that left side. And on the right, we square the 2, and we get 4. Okay, we're just taking the things we've learned in this chapter, roots, and applying it to our year-long goal of finding the mystery number. Now we're in Algebra 1, pre-algebra, 8th grade math, whatever you want to call it, getting the x by itself. Subtract 8 to the other side. 4x equals negative 4. Divide by 4. You get x equals negative 1. Put the negative 1 in to make sure that the left side equals 9. 4 times negative 1 is negative 4. Negative 4 plus 8 is 4. Square root of 4 is 2. And 2 plus 7 is definitely 9. So we are good. I want you to try one. I want you to solve that one for y. Okay, what you should have done is add 1. One thing you have to make sure of is you know that the minus 1 is outside the root and the minus 2 is inside the root. Sometimes I put a tail on the end of my root. You see that I added to make sure that separates the inside from the outside. Square both sides. Add 2. And then check your answer. And it works. Questions there? All right. Now let's do one that has a fraction exponent as opposed to a root. Doesn't really make it any more difficult. Just have to be aware of the nomenclature. A fraction exponent, as we learned yesterday, is basically a root. So we have to get that root by itself. So the first thing I'm going to do is subtract 5 to the other side. And now what I would probably do is change it to a root. How would a 1/3 exponent be written as a root? What would it look like? Yes? Yes. Talked about that yesterday. You have to be able to do that. 1/3 exponent means cube root. And so now you have to adjust your thinking from the previous problems. How do I get rid of a cube root? You cube it. So in this case, instead of squaring both sides, we're going to take both sides to the 3rd power. Whatever the index is the power you take. That's how you battle it. That's how you neutralize it. Okay? It's not always squaring. It's not always one thing. Depends on the problem. You can't use one solving mechanism for every problem. So you get 3y plus 1 on this side, negative 125 over here. Subtract the 1, and then divide by 3. I get negative 42. Checking your answer, you put it back in somewhere and check it. And you really don't need to check cube roots. The only ones you have to check are square roots. Those are the only ones that can screw you up. The ones where you could have potential imaginaries, and you could only have imaginaries for even index problems. Odd index problems doesn't really matter. Okay, now we're going to look at something just a little bit different, not tremendously different. We're going to look at an inequality. And all this does is it adds something on to the tail end of the problem. The beginning of the problem is going to be done the exact same way. You'll notice here we have less than or equal to as opposed to equal to. All right, so we want to know the x's that we could put in that will give us a true statement. So to solve this, we're going to subtract 4, like normal, as if it was equals. The square root of 3x minus 6 is less than or equal to 3. And then square both sides. 3x minus 6 is less than or equal to 9. Standard, just like we've been doing. Add the 6. Divide by 3. I get x is less than or equal to 5. So what I'm saying here is that all numbers less than 5 work. Right? So any number that I would put in less than 5 would work. So let's try 2. 3 times 2 is 6. 6 minus 6 is 0. Square root of 0 is 0. 0 plus 4 is 4. Is 4 less than or equal to 7? Yes. What about if we try negative 1? 3 times negative 1 is negative 3. Negative 3 minus 6 is negative 9. What's the square root of negative 9? 3i. What's 3i plus 4?
7i.
No. 3i plus 4 is 3i plus 4. Is 3i plus 4 less than or equal to 7? I don't know, because you can't compare an imaginary to a real. we have a problem. Because there are certain numbers that when you put them in, you get an imaginary, and we can't really compare those. So we have to figure out what numbers we can put in and compare and not compare. Here's how you do that. You go back to earlier in this chapter, I believe, we have to figure out where this graph is born. And we did those graphs. We had to figure out where it starts to exist. We have to do that here. We take the innards of the root and we figure out where it starts. Because before it starts, it wasn't existing, nothing was happening. Remember when we shaded those graphs, we only shaded to where it was born? Well, this only exists to where it was born. Our answer is only going to be there. So we have to set the innards equal to 0, solve, and it starts at 2. So our answers are only going to start at 2. So our answers that we found before were all numbers less than or equal to 5, but that only goes down to 2. So you're going to get kind of a compound inequality, part of it from your regular solving, x is less than or equal to 5, and then part of it from finding out where the graph is born, where you start to get real numbers as opposed to imaginary numbers. All right? You try this one. Step 1, add the 2, square both sides, add the 4, divide by 4. My first part of my compound inequality is x is less than 10. Now I have to figure out where this thing starts to exist because it's not going to be all numbers less than or equal to 10. I can see right now if I put in negative 100, that's going to be imaginary. So I've got to figure out where things start to become real. So I set it equal to 0, add 4, divide by 4. It's going to be 1, and I put less than or equal to, because it does exist at 1. That gives me square root of 0. So 1 counts. That's why you have to put less than or equal to. It's not just less than. If 1 gave me an imaginary somehow, but everything up to 1 worked, it would be less than. But since 1 does work, you put less than or equal to. So what I'm saying is the only numbers that you could put into the green X to give you a true statement on the left side is the numbers between 1 and 10, 1 inclusive.